The Simulation Hypothesis. Decoding Reality Table of Contents. 1. Introduction to the Simulation Hypothesis. An overview of the role of science and conspiracy in shaping our perception of reality. 2. Foundations of the Simulation Hypothesis. Plato's Allegory of the Cave. Reference. Plato, The Republic. René Descartes and the Evil Demon. Reference. Descartes, Meditations on First Philosophy. The Brain in a Vat Theory. Reference. Hilary Putnam, Reason, Truth and History. 3. The Holographic Principle. Theoretical Foundations. Reference. Gerard, T. Hooft, Dimensional Reduction in Quantum Gravity. Black Hole Information Paradox and Holography. Reference. Leonard Susskind, The World as a Hologram. Implications for the Nature of Reality. 4. Quantum Mechanics and the Nature of Reality. The Double-Slit Experiment. Reference. Thomas Young, Experiments and Calculations Relative to Physical Optics. The Observer Effect and Wave-Particle Duality. Reference. W. Heisenberg, The Physical Principles of the Quantum Theory. The Many Worlds Interpretation. Reference. Hugh Everett, Relative State Formulation of Quantum Mechanics. 5. Digital Physics and Information Theory. The Cellular Automaton Hypothesis. Reference. Stephen Wolfram, A New Kind of Science. The Universe as a Quantum Computer. Reference. Seth Lloyd, Programming the Universe. Information Theory and the Nature of Reality. Reference. Claude Shannon, A Mathematical Theory of Communication. 6. The Technological Argument for the Simulation Hypothesis. The Development of Virtual Reality and Holography. Reference. Jaron Lanier, Dawn of the New Everything. Advancements in Artificial Intelligence and Machine Learning. Reference. Max Tegmark, Life 3.0. The Bostrom Argument. Reference. Nick Bostrom, Are You Living in a Computer Simulation? 7. Challenges and Criticisms of the Simulation Hypothesis. The Problem of Induction. Reference. David Hume, An Enquiry Concerning Human Understanding. Quantum Computing Limitations. Reference. Scott Aaronson, The Limits of Quantum Computers. The Energy and Computational Requirements of Simulating Reality. 8. The Role of Consciousness in the Simulation Hypothesis. Panpsychism and the Integrated Information Theory. Reference. Giulio Tononi, Consciousness as Integrated Information. The Hard Problem of Consciousness. Reference. David Chalmers, Facing Up to the Problem of Consciousness. 9. Ethical and Philosophical Implications of the Simulation Hypothesis. Simulated Suffering and Moral Responsibility. Reference. Peter Singer, Famine, Affluence, and Morality. The Meaning of Life in a Simulated Universe. Reference. Albert Camus, The Myth of Sisyphus. 10. Conclusion. The Future of the Simulation Hypothesis Debate. The Importance of Continued Inquiry and Exploration. This book will explore the various theories, scientific findings, and philosophical debates surrounding the simulation hypothesis. Each chapter will delve into the history, current understanding, and potential implications of the hypothesis, highlighting key references and arguments from proponents and critics alike. The goal of this book is to provide a comprehensive understanding of the simulation hypothesis and its implications for our perception of reality. Chapter 1. Chapter 1. Introduction 1.1 The Simulation Hypothesis, an Overview. The simulation hypothesis posits that our reality might be a computer-generated simulation, much like a virtual reality or a hologram. This idea has gained traction in recent years, fueled by advancements in technology, computing, and our understanding of the universe. While the notion may seem far-fetched at first glance, some prominent scientists, philosophers, and tech entrepreneurs have given serious consideration to the possibility. In this chapter, we will provide an overview of the simulation hypothesis, outlining its core concepts and explaining why it has garnered attention in various academic and popular circles. 1.2 The role of science and conspiracy in shaping our perception of reality. Science has played a significant role in shaping our understanding of the universe, and in recent years, some scientific discoveries have lent credence to the notion that our reality could be a simulation. For instance, the holographic principle, derived from the study of black holes and quantum gravity, suggests that our three-dimensional world might be a projection of a two-dimensional surface. Additionally, the field of quantum mechanics has challenged our traditional notions of reality, with phenomena like wave-particle duality and the observer effect raising questions about the true nature of the physical world. While science has advanced our knowledge of the universe, it has also given rise to conspiracy theories and fringe beliefs. In the context of the simulation hypothesis, some individuals have drawn connections between the idea and various conspiracies, such as alien intervention or secret government projects. It is crucial to distinguish between scientific inquiry and conspiracy theories, as the former is based on empirical evidence, rigorous methodology, and logical reasoning, while the latter often relies on speculation, misinformation, and unfounded beliefs. As we delve deeper into the chapters that follow, we will explore the scientific and philosophical foundations of the simulation hypothesis, examining the various theories and evidence that support or challenge the idea. We will also discuss the ethical and existential implications of living in a simulated reality, and consider the potential consequences of such a revelation for our understanding of the universe and our place within it. Chapter 10. Final Thoughts and the Pursuit of Knowledge. 10.1 The Importance of Open Inquiry. The simulation hypothesis is a provocative and challenging idea that has captured the imagination of scientists, philosophers, and the general public alike. While it remains a topic of ongoing debate and speculation, its exploration serves as a reminder of the importance of open inquiry and the pursuit of knowledge. As we continue to question the nature of reality and our place within it, we must remain open to new ideas and possibilities that challenge our assumptions and expand our understanding. 10.2 The Role of Interdisciplinary Collaboration. The investigation of the simulation hypothesis is inherently interdisciplinary, drawing on insights from physics, computer science, philosophy, and other fields. This collaboration highlights the value of interdisciplinary research in addressing complex questions and advancing our understanding of the universe. As we continue to explore the simulation hypothesis and other challenging topics, it is essential to foster dialogue and cooperation among researchers from diverse backgrounds and perspectives. 10.3 Embracing Uncertainty and the Spirit of Exploration. The simulation hypothesis serves as a reminder of the inherent uncertainty and mystery that surround our understanding of reality. As we continue to explore this idea and other intriguing concepts, it is essential to embrace the spirit of exploration and curiosity that has driven human progress throughout history. By acknowledging the limits of our knowledge and remaining open to new discoveries, we can continue to push the boundaries of understanding and enrich our collective experience of the world. 10.4 The Impact on Our Daily Lives. While the simulation hypothesis may seem abstract and disconnected from our everyday lives, it has the potential to influence the way we view ourselves, our relationships, and our place in the universe. Whether or not we ultimately determine that our reality is a simulation, the exploration of this idea can inspire us to reflect on the nature of existence, the value of our experiences, and the meaning we ascribe to our lives. In this final chapter, we have reflected on the importance of open inquiry, interdisciplinary collaboration, and embracing uncertainty in the pursuit of knowledge. As we continue to investigate the simulation hypothesis and other challenging questions, we must remain committed to the spirit of exploration that has driven human progress throughout history. By doing so, we can continue to expand our understanding of the universe and our place within it, and inspire future generations to seek answers to the mysteries that still await discovery. Chapter 11. The Influence of the Simulation Hypothesis on Culture and Society. 11.1 The Simulation Hypothesis in Popular Culture. The simulation hypothesis has made a significant impact on popular culture, with movies, books, and other media exploring the idea of simulated realities. Films like The Matrix and Inception have brought the concept to mainstream audiences, while books such as The Three-Body Problem and Ready Player One have delved into the implications of living in a virtual world. The simulation hypothesis has also inspired numerous works of art, music, and interactive experiences that invite audiences to reflect on the nature of reality and their place within it. 11.2 The simulation hypothesis and religion. The simulation hypothesis has also generated interest and debate within religious and spiritual communities. Some have drawn parallels between the idea of a simulated reality and religious concepts such as creation, divine intervention, and the nature of existence. Others have argued that the simulation hypothesis challenges traditional religious beliefs or offers a new perspective on the nature of God or a higher power. These discussions highlight the ways in which the simulation hypothesis intersects with and influences spiritual and religious thought. 11.3 The simulation hypothesis and education. The simulation hypothesis has implications for education and the ways in which we teach and learn about the nature of reality. As educators and students grapple with the idea that our universe might be a simulation, it can encourage critical thinking, interdisciplinary inquiry, and creative problem-solving. By incorporating the simulation hypothesis into discussions about physics, computer science, philosophy, and other subjects, educators can engage students in a thought-provoking exploration of the boundaries of human knowledge. 11.4 The simulation hypothesis as a catalyst for change. The simulation hypothesis has the potential to serve as a catalyst for change, prompting individuals and societies to reconsider their values, beliefs, and priorities. If our reality is a simulation, it invites us to question our assumptions about the nature of existence, the meaning of life, and our relationship to the world around us. By grappling with these questions, we can foster a greater sense of empathy, compassion, and understanding, and encourage a more thoughtful and reflective approach to our lives and the decisions we make. In this chapter, we have explored the influence of the simulation hypothesis on culture and society, examining its impact on popular culture, religion, education, and personal values. As we continue to investigate the simulation hypothesis and other challenging ideas, it is essential to recognize the ways in which these concepts can shape our understanding of ourselves, our world, and our place within it. By engaging with these ideas and their implications, we can foster a deeper sense of curiosity, wonder, and appreciation for the mysteries and complexities of the universe. 12. Incorporate the latest thoughts including quantum ideas and Elon Musk's take on it. Chapter 12. New Frontiers, Quantum Reality, AI, and Elon Musk's Simulation View. 12.1 The latest quantum angle. Modern physics has not proven that reality is a computer simulation, but several serious theories make reality look less like solid stuff, and more like information, fields, probability, and geometry. In quantum theory, particles behave like waves of possibility until measured. In holographic physics, spacetime may emerge from lower-dimensional information. Recent holography work continues exploring how gravity, quantum chaos, and boundary information may connect, especially through models like SYK and Jaku-Teitelbaum gravity. The key thought is this: if matter is energy, and energy is structured by fields, information, and resonance, then physical reality may be a stable pattern rather than a pile of tiny hard objects. 12.2 The hologram is not the same as a video game. The scientific holographic principle does not mean the universe is literally a movie projection. It means the information describing a volume of space may be encoded on a lower dimensional boundary. This idea came from black hole physics and remains one of the major pathways toward quantum gravity. Recent summaries still describe holography as a promising route where spacetime geometry may be emergent from deeper quantum information. So the hologram idea is partly science, partly metaphor, and partly popular imagination. 12.3 Elon Musk's take. Elon Musk has famously argued that the odds we are in base reality may be very low. His reasoning follows the same basic path as Nick Bostrom. If civilizations eventually create many realistic ancestor simulations, then simulated realities could vastly outnumber original realities. Musk's widely quoted position is that the chance of being in base reality could be 1 in billions. This is not proof. It is a probability argument based on future technology, AI, virtual worlds, and the assumption that conscious simulations are possible. 12.4 Bostrom, Bayesian pushback, and the 50-50 problem. Bostrom's original 2003 argument says one of three things is likely true. Civilizations go extinct before reaching simulation-level technology. Advanced civilizations choose not to run many ancestor simulations, or we are probably in a simulation. But later Bayesian analysis by David Kipping argued that, because we do not yet know whether such simulations are possible, the probability may be closer to less than 50% unless humanity actually creates convincing conscious simulations. 12.5 AI as the new accelerator. AI changes the discussion. If AI systems become capable of generating realistic worlds, agents, memories, physics engines, and simulated societies, then the simulation hypothesis becomes less like fantasy and more like a future engineering question. Musk has also warned about AI risk while predicting rapid advances in machine intelligence. For this book, the important point is simple. AI may become the mirror by which humanity learns whether mind, matter, and world building can be digitally reproduced. 12.6 Fact, Fiction, and the Wizard's Middle Path. Fact. Physics increasingly treats information as fundamental. Fact. Quantum mechanics challenges ordinary material realism. Fact. Holography is a serious scientific framework. Fiction. Speculation. That glitches, déjà vu, Mandela effects, or synchronicities prove we live in a simulation. Open question. Whether consciousness can be simulated. The wise position is neither blind belief nor automatic dismissal. The simulation hypothesis is best treated as a philosophical, scientific, and technological doorway. A way to ask what reality is made of, what consciousness is, and whether the universe is matter pretending to be information, or information pretending to be matter. Global Robotics Corporation. Robert Coley.